We're recording now.
Right.
There we go.
Can see you.
Can see us.
Oh, you know what?
We can't hide.
I'll have this
You
one.
can turn that one off. You
Okay,
hear double.
I'll turn it off.
You guys can tell me if you're seeing everything or not.
Yeah, I'll keep an eye out for that. But in the meantime, yeah, I'm looking at the students. Let's see. Audrey's here. I wonder if she advertised it on Facebook also. Yeah, they're coming. They'll drop in.
No, we're good. We looks like you're all set up.
I think so. That everybody's joining from their homes, and I told them to have a microphone and speakers and a webcam. If they
That's
can.
great. So we should have plenty in store for you guys. It's a very customized presentation.
Great. I appreciate it. Yeah, it looks very, very professional. Everybody has a logo also.
Oh, that's
Yeah,
right.
I sort of made him do it, so you know.
It's important. Yeah.
It is, you know, as much branding as you can do. It's even if it's subliminal. I have some other shirts that I don't really like always the really, you know, this is really white kind of look. So I've got some other like black shirts that have like silver font, super nice. Everybody's always jealous of them. The company
yeah.
really doesn't like it though. It's not, you know, official. But
They're more like an evening outfit.
yeah, it's evening, and it's a lot of people, a lot of designers that I present to. Not that they don't, they dress nicely, but typically there's a lot of black and there's a lot of shirt tails untucked. So that's what I do, you know.
Okay, sounds great. So I feel like
was that Jessica's teeth in there or something?
she doesn't. She's shy. She doesn't want to share her camera.
No, she did at the beginning. She did a hi, so that was nice.
But we need to give him the option to exercise their right to privacy.
No, I totally agree with that. That's one thing that makes it a little bit difficult sometimes is some of the trainings you'll see on here, a couple of videos, as long as everything works like it's supposed to be working, are students, either students or actually people from their office. Some of them new to irrigation, some that have been in it for a while, but I've gotten the okay from a few of them to put them on YouTube. Some people have a problem with that. Most of them are pretty good. There's nothing compromising in there, but they're helpful especially helpful for me. I use YouTube on a very regular basis, you know, for teaching and entertainment. You know, some of it's just fun. So.
Mm-hmm. Yeah, no, it sounds great. It's great to mix it up, mix different media. I mean, you can announce it. I think there should be a few more.
Okay. No, it's right on. I think we're right on. That we have this with. It's funny with work. We typically do just audio. We don't do a lot of video. But whenever I hold a meeting, I try to do the video so they get more used to that. Because you know the same thing. Body language. It's tough to get on audio. So.
No, that's true.
Yeah. Let's see. 1.6 has to be a few more. But let me know when you read. Yeah, let us know when you have to start. You know, so I mean, maybe they can, since we're recording, they can catch up on the early information.
Oh,
maybe not.
Yeah,
trickle in.
Yeah, there's no timing as long as it's not tomorrow or something. But if
No, just give it-
we're on. We used to have. Do you guys have this at school? I don't know. They like if you were if you had your bachelor's, right? You wait for about 5 or 10 minutes, and I guess if you
Yeah.
have a PhD, right, you have to like wait an hour. So
No, I mean, it's the same as like academic sort of delay, you know, an academic allowance, but they're dropping in.
so on your screen, what are you seeing? Just us?
Yeah,
Okay, sorry, but that's all we have.
No.
but I saw a PowerPoint earlier. So,
Yes.
you're gonna, yeah. So
That will come.
Right.
That will come back. We hope.
now, I just,
Imagine if it was just us the whole time.
okay.
It could be. Yeah, I've used this Zoom format for a little bit. Part of the difficulty is always trying to do some new things and switching back and forth between, video, PowerPoint, all the stuff you do it. It gets a little bit tricky. So I was even talking to the Zoom guy about an hour ago saying, the nice thing is they have 24-hour help if you need it. I usually don't need it that much, but every now and then it's like, what button am I not clicking? So.
Yeah, I only use it for meetings, but I never used it for teaching. I told you about Adobe Connect. That's the one we use in
Well-
our remote teaching.
Well, on that Adobe Connect, will that can you have a certain number of users or as many as you want? Or hello,
You can have.
hi Tina,
Hello.
you're down there somewhere.
Yeah, yeah. You can have as many as you want. It's
Sure.
very. I've had like 200 people participate in a lecture.
Oh, that's good.
And it's pretty stable. So what do we do here? Do we want to start?
Yeah, we can start because that way we do our introductions and that kind of thing.
Yeah. Okay.
Let's go ahead. You want to? Well,
Yeah, sure.
Yeah,
That's nice.
let me get that slide up here. So make it a little bit. All right.
Okay, so I'll start off by introducing myself. My name is Fernando Terrazas. I'm a contractor and distribution account manager for Rainbird in the Bay Area. So I deal mostly with distributors and on that level. And I manage accounts for them for the largest ones. So Horizon, Ewing, SiteOne. And that's my introduction.
That works. I'm Mark Hall. My name's really easy because you just turn around backwards and you got it figured out. Hallmark. And my background is I'm a licensed landscape architect. I went to Cal Poly Pomona, got my degree there. And I'm also area specification manager for Rainbird. And what that means is I cover the Bay Area. So the people I call on are irrigation consultants and landscape architects. So I'm calling on all of those. I've done things with contractors. I am a contractor myself also, so I like a lot of hands-on training. Sorry that the smoke thing didn't work out. Nothing we could do about that. But you know what? Sometimes I think it's a nice opportunity to do something different like this because we are doing more of this type of communication with our specifiers. They have 20 minutes sometimes, but that's about all we need. So today is a lot more thorough than call it your typical, let's say, go over a single product or a new product or anything like that. This we're actually going to do a run through like we would have done in your class, and we will make it as live as possible so you guys can get an idea of sort of how we go about our teaching. I'll go ahead and as long as everybody can hear me and see me, or at least hear me. And please, if you have any questions, just let me know. I wanted to just start off with, and I'm going to make the assumption, I talked to Denny about this, that the irrigation experience may be minimal unless you're already doing some type of internship. So keep that in mind. So if I'm sounding very basic, that's why. So this particular plan, this is a nice graphic that gives you an idea of just from a residential standpoint and a garage. And you'll see this has a pool and you've got hardscape in here. The softscape, you can barely see that, which is good. It's like they layered that back so you can see the shrubs, ground cover. In this case, there's stepping stones, there's turf areas, a little bit of everything. So this is what we're looking, hopefully by the end of this, you guys will be able to do something like this, or at least have an idea of how to go about it and whether it's something that you want to continue with yourself. I personally think, I call it irritation, not irrigation, because most landscape architects and designers do not really like irrigation. So my number one goal is to make it fun and memorable. And then hopefully there'll be some educational parts in here, a little bit of math, a little bit of hydraulics, a little bit of everything. I'm cramming 15 years, maybe 20 years into a couple hours or less. That's what you're gonna get, and hopefully this will work for you. Now I wanted to start out with a couple things that are really important. Is why should irrigation be important to you? Over the years, I found this out myself. Besides being a sales rep, I've worked with multiple manufacturers. I've worked as a designer in my own business. I've just bounced around a lot more than I thought I would, but that's the way it is today. The average person coming out of school has 30 jobs in their lifetime. So you might want to take this seriously as far as irrigation goes, because it's one more skill that you can offer. A lot of times you'll actually can market yourself as, hey, I'm worth more than the guy or girl next to me. And also in the recruitment process, when you look at LinkedIn, and that's where almost everybody goes now, if you have those within your resume about irrigation, you have a better chance of getting a job. There are also licenses that you can get. There's CID, which is a Certified Irrigation Designer, or you can get a CLIA, which is a Certified Landscape Irrigation Auditor. I do not have either of those. I need them. I think I could do them just fine, but you know, it's great if you have the more and acronyms and stuff that you have behind your name, the better off. When economy changes, I've seen a lot of offices when economy goes way down or slows down, they usually keep the people that do landscape architecture, landscape design, or softscape or theory, and they do irrigation. So you're gonna protect yourself from possible layoffs down the road if you do that. Now, if you look at the Bay Area, the area that I cover, a lot of the offices and the large offices, CMG, and a bunch of other ones, they sub it out. They sub out the irrigation. So they do all the planting and hardscape and siding of buildings and everything else, but they sub out the irrigation. But you need to know enough about irrigation so you can check their work. You are liable for their irrigation work. They're liable too, but you're the one that they're going to include that within your plan set. We're going to start covering just about spray and rotary nozzles or sprinklers, whatever you want to call them. It's just an efficient way to put down water evenly over medium, small, large spaces. So these are a couple different examples. So right now, it's sort of just sit back, take a look at these particular products, and I'll give you an idea of what they do. And what are some of the important things? There's a lot of legislation out now that requires certain things, like this particular is a pop-up spray head. And these will pop up 6, 12, or 18 inches. I'm sorry, 12, 6, or 4 inches high. It's called a SAM series, this particular one. SAM means Seal-O-Matic. So what that is is when you have a bunch of these spray heads on a slope and you turn everything off, you'll typically get drainage towards the toe or the base of the slope. That causes erosion. That also on your end can cause liability. So we put a check valve right at the base of the head. So when the water shuts off, every single one of these will turn off up to 14 feet, which means you will not get this drainage, which also means you'll have even watering for your planting. Another thing that we can include with our spray heads, and most designers do this now, I'm not going to say necessarily most contractors do, but most designers do this. They use a PRS, which is a pressure regulating stem. The pressure regulating stem and a spray head like down below here, you're going to see these right here. We actually put a gauge on this. And this particular one has no regulation. It's all the fogging and misting. So this is putting out 1.64 gallons per minute. So just think of it, you know, as you're putting down almost 2 gallons of water in a minute. But if you go over to here where it's actually regulated per manufacturer's guidelines and instructions, you can go down to less than 1 gallon a minute. So you're wasting a lot of water if you don't have this added feature. It's an inexpensive feature, and I'm not trying to sell you guys on anything. There's other manufacturers that have this also. Rainbird was the first in this case, but it's nice to have the Seal-O-Matic, and it's nice to have the pressure regulator. Another thing the pressure regulator does that I think, I didn't even realize this when I started, that if you have a pressure regulator in, it actually keeps, when a nozzle gets taken off, stolen, vandalized, broken, right here, the stem will regulate that, or actually throttle back the water to just a couple feet high, where if you don't have it, it's going to shoot up like this, and you're going to lose a lot more water, and there's going to be erosion. Rainbird came up with this quite some time ago. You'll see this nozzle, and I'll show you another picture of this. This is actually showing our U-Series nozzle, and it has an undercut. The undercut is so it sprays really close to the head, so it's more efficient, and you don't have to go back and water these areas that are starting to die. So this U-Series is a more efficient way to water. If you look at a sort of a side view of this, this is super accurate, sort of a funky sketch for designers, but it's what I have. So here we have good spray, and best you can see you have like 2 fanning of the water. It's fanning out, but this goes really close into the nozzle. All these things are important. If you want to protect yourself and you're doing design, or you have somebody doing design for you, you just want to, these should be standard. I made them standard years ago. I worked for Stantec Consulting for a while. We did that with everything. We didn't shortchange. It's not that expensive. If you have a $100,000 landscape, you might have a $5,000 irrigation system. Gives you a little bit of idea. HEVAN means high efficiency variable arc nozzle. High efficiency variable arc. I had this on here just in case I would forget, but I didn't. So on here you have, this is something that's fairly new. Our van nozzles, I have to say, years ago were not that reliable. They would come out of adjustment. These particular ones, they don't come out of adjustment. And I'll show you what that looks like. Right here, you get an idea. You can adjust these to any angle up to, what was it, 270?
Mm-hmm.
Okay, that's why I have Fernando here. So, no, he's got a lot more to do. So, and you can see this edge. We call it exact edge technology. This is a big deal. Hard to believe it's a big deal, but it is, because if you can't get close to your sidewalk like this or mow strip, you're not going to get even watering. You're not going to get true coverage. These are also larger droplets. We call it rain curtain technology, and what that does is that makes it so it goes through the wind. You've seen, I'm sure, if you walk by somewhere where things are just misting all over the sidewalk, this helps prevent that misting. All right, so this is, some of these pictures are like from the lab picture. You wouldn't see this out in the open. Most of the testing is actually done in labs or in a building, which, you know, for me, when I came in, I said, well, is that really a true measure of a spray head or a rotor head? And well, the reality is if you get a little bit of wind, it throws the calcs, most of them, out the window. So you have to do it in a perfect condition, but there's some adjustments that you can make on droplet size. In this case, you can see, look how low this HE van. We decided we were going to lower this a little bit, so that way we'd have less wind drift. We're on here, and we are going to talk about, I just let you know up front, we will talk about, used to be hush-hush to talk about competitors' products, but it's the only way for us to make true comparisons. We're not going to come to you and lie about anything. There's no reason to do that. But in this industry, it's a very tight industry. You want to make sure you're telling the true story, not making something up. So if you hear Hunter or you hear Toro or any of the other ones, we're doing them for a comparison. Otherwise, we're just comparing to ourselves, and that doesn't do a heck of a lot. R-series rotary nozzles. Rotary nozzles become much more popular over time, and part of it, believe it or not, is people like the way they look. You know, they like the little stream throw, and it's turning, and the stream throw's coming out. Now these are fixed, so this actually is going to do a 360-degree area, and that's all it can do. And there's the radius of it. There's our competitors that have this too, and I'll show you one in a video in a second. Let's see, go next one. And so there's the arc range. These are variable arc nozzles. These are fairly new. We've had to do a lot of improvements to compete with other manufacturers. It's not all about just having a great head. It's having a better head, better nozzle, because they'll do the same thing to us. Eventually patents run out. But this gives you an idea. There's a couple different models here. The range is 13 to 18 or 17 to 24. And we will put this into a practical format for you in a second. If you look on here, this is how it's adjusted. You really just have to push down and turn. And it even has the arrows and plus or minus, and you can change this dimension here on the arc. You can also change the radius all with your hand. Now, most probably wouldn't think that that's that big of a deal. But other manufacturers right now, the only way you can do this is there's a screw in here, and it takes a special tool to adjust this. This takes no tool. It's huge, and you can also flush it just from the head, but you got to do this while it's running. That's just the way those work. You can see a few of them right here. What's unusual about this is you see a rotor head. Now the rotor head, you can actually use all four of these together. That's not normal. Normally, these put out a certain, we call it precipitation rate, certain amount of water over every square foot of an area. So if this is a 0.6 precipitation rate, then this has to be the same to work on the same system. So there's some pluses and cons to that, but most of them are plus because you've got the same precipitation whether you want it. So what it means is you could put all these heads on the same system. Normally, you have to put this on a separate system or a separate valve or station. Check valves, I'm real big on check valves. Everything should have check valves. It saves a lot of water. We do work with a lot of non-potable or recycled water, reclaimed water. We also, here's the SAN PRS. That's what that looks like from the cap. Here's another SAN PRS. Remember that's Seal-O-Matic that has a check valve on it, and it's pressure regulating stem. So the nice thing about that, whatever you put in, you get out exactly what you need. So in here, let's say on this particular head, if you put in 40 pounds of pressure, you get 30 PSI coming out. So it's really nice. In fact, if your design isn't that perfect, this will make up for it. And then this is our drip line. This has emitters inside the drip line. Most, at least since I started, it used to be about 20% of all projects were drip. Now I think it's about 80 to 90% of all projects are drip. So drip has become more and more important for multiple reasons. A lot of it's legislation, but it's efficient. So people are having to learn. We will show you a little bit more about drip in a bit. Just a lot of information. So hopefully we'll have a test. No, we won't have a test. But I thought about having a test on how many slides. No. So on here, this is a nice little quick diagram that I found. You can see here, this is actually a controller. And back in here is a computer screen. So this runs all the irrigation. We'll show you this later. And then this ties in this case, to a rain sensor. And when it gets moist, there's hydroscopic discs that expand, and then it shuts this down. Once this dries, it opens up the connection and then lets this run. So when you come down here, you're going to see what's really showing is like 3 systems. This is not how it would be laid out. So this has a large valve in this case because these are rotors in here. You've got rotor heads which put out more water. So these could put out 15 gallons a minute, 20 gallons a minute, where the spray heads, like down below here, might be putting out 1, 2, or 4 gallons per minute. And we go down to here, so you can see the valves. Look at the size of the valves. Then you go down to here, and you have, for drip, you have a valve, a filter, and a regulator to run. Remember that drip line in that round coil? You can run drip. And then there's another type of drip. We'll talk about that later on. Any questions at all so far? Keep moving. We'll keep moving. We good, Denny?
I mean, just give me a few seconds. Questions?
Oh yeah, whatever you got.
You can connect your microphone. You don't have to have a video if you don't want to.
I don't have to have what?
Oh, for the students.
They don't.
Oh yeah.
They don't. It looks like there's no questions though. Otherwise, they probably would have spoken up.
Okay.
There's also a chat.
No problem.
They can use. They could use a chat if they want to ask questions.
That's true. That's a good feature.
Okay.
Okay, you ready? We're good. So this is an irrigation plan. Looks real exciting. I know it's not like doing hardscape, softscape, and this is actually a fairly simple design. This is all in rectangles, or I call rectilinear versus doing curvilinear. I know we do every shape imaginable. That's one thing that you may not think about. It's like, for instance, think about Disney. Disney Shanghai is one place. Actually, my son's a irrigation consultant, or he was, and the irrigation consultant does all the Disneys worldwide, and he was working on the Shanghai one, and I'm like, oh, okay, so what's so difficult about Disney? Well, Disney, they do every shape you can think of, every elevation. It's very challenging, and they expect perfection. So if you're irrigation, you know what you're doing. You can design any size of shape that you want. You can do a green wall, you could do a green roof, you could do things out of pipes, you could do, any shape. So you can water underground on the lawn, which not a lot do, but it's a great way to go. So on here is just basic. These are actually, you'll see here, down at the bottom, there's a water meter, an example, backflow. What a backflow is, we're not going to go through it, but it keeps all basically the dirty water from coming back into your house so you don't drink it. So it's a pretty big part of the system, and it's required by law. You have to get a permit on that. And you go over here, and here's a valve, and here's a controller. Those are standard symbols. They're not used all the time, but they're used most of the time, or something similar. And then you'll see these valves, and each valve controls a different area. And I'll move to that to clean it up a little bit. If you look into here, you have all the same symbols, but what I've done is I've made it so you can see a single zone or a single area. So all these heads, this is a sprinkler head, 1, 2, 3, 4, and there's another 4 down here. And this line is showing coverage, or basically the distance that a spray head can spray. So this is a nice little sketch. We'll be doing this actual thing in my living room, but we may not turn on the system. We haven't decided. So PVC, I didn't even think about what it was, but it's polyvinyl chloride. And we're going to talk about pipe sizing. Now this is a little bit tricky, but we're going to do it two ways. One, we're going to do it here on the computer, and then we're going to take a look down into my little living room, and we're going to build a system. So, and then you'll learn how to size things appropriately. I think it will help. I've done it before. I did it for anybody ever heard of Master Gardeners. First time I ever did this. The Master Gardeners, they require 6 hours of irrigation, and everybody in that class is probably 70 years to 90 years old. So, and they never had done any irrigation. So anyway, I came up with this new method. So what I did is I took a bunch of technical stuff that we have in this presentation, and we've also put something that I think everybody will understand, including myself. So if you look here, these are different PVC pipes to carry the water to the spray heads. This is 3/4. No, this is a 1/2 inch, 3/4 inch, 1 inch, 1.25 inches, 1.5 inches, 2 inch, most likely a 3-inch pipe. Okay, so all those are different. They have different flow characteristics. So you guys can still see things fine? So my thing was, okay. So when you look inside a pipe and you look at the outside or the end like we were sort of looking at, you're gonna see there's gonna be outside diameter, there's gonna be an inside diameter, and then there's gonna be the difference between those two, which is the wall thickness. Okay, now look at this picture. This picture here is the same thing, but you can sort of see down a pipe here. Now, when you're pushing water down this pipe, the smaller the pipe, the more friction there is. So why is that a big deal? If you're going through, if you have too much, I went too far, sorry about that. If you have too much friction loss, your spray heads may not operate properly. So you have to size the pipe correctly. Yeah, it's sort of a pain, but once you've done it a few times, or like some of the irrigation designers have done 1,000,000 times, they don't even have to look at a chart. But we do have charts that you can look at in the back of our catalog. And if you want those, I think we even have it available online. So you can get the catalog online, but you can also get a hard copy if you need to. So water, we've got to design our pipe appropriately for the spray heads to work. That's really what it comes down to. So here's a really fun chart. Not too fun. But once you find out, it's a great cheat sheet. And they do, I think they've automated some of these charts online, so you probably don't even have to really think that much. One of the advantages we have when we get out of school, and with Google and everything else that's out there, you know, we can get the answer to most of this. So friction loss and pipe sizing. Now you'll see at the top here, these are the sizes of the pipe. If you remember that picture I just had shown you. So 1/2, 3/4, 1 inch, 1.25 inches, and so on. And this shows the schedule of the pipe, schedule 40, which is a fairly heavy wall pipe when you look at the smaller pipe sizes. I won't get into that because there's a lot to that. So we're going to talk about the 3/4, the 1 inch, and the 1.25 inches. And there's a reason for this, and you'll find out in a little bit. Now you're going to see here, see this shaded area down below? Now let's take 3/4 inch. Once you get here, where that shade is, you're not supposed to use that pipe anymore. Because if you have more than 5 feet per second, they call it, it's too much friction loss for the pipe to run appropriately. So you have to go down to the next one, which is the 1 inch pipe, and so on and so forth, all the way down. The bigger the pipe, the less friction loss there is. Did you say something, Denny?
So Mark, I have a question.
Yes, sir.
So how do you I mean, you have to establish how much sort of water, the water intensity that you want. And is this based on the number of nozzles that you have on one line, on one pipe?
Yes, great
So if you have-
question.
yeah.
Great question. It is, and it's funny that you mentioned that. There's two ways to do this. There's a way to do it beforehand or a way to do it after. So I'm sort of giving the overall, and then I will answer those questions. And you're right. It all has to do with that. In fact, you were ahead of it. You're like right on.
Okay.
There's the sizes. And if I click again, so if your gallons, these are gallons per minute on this side. So if you have 3 spray heads that equal 7 gallons per minute, this is what your pressure loss is, 4.42 PSI. Now, what if I wanted less pressure loss? I can go to a larger, 1.25 inches even, and my pressure loss is almost a quarter of what the 3/4 was. But, you know, the cost of PVC can be fairly expensive, so you want to keep it close, not too close, but as long as you're above this line, you should be safe. But yeah, we'll show you some of the head thing. You'll see here, here's for 12 gallons a minute. So that could be, let's say 6 heads, and there's your loss. Now this loss of pressure is per every 100 feet. That's super important to remember because I'll tell you, first I just added these for pressure loss, and that's not correct. It depends on how long the pipe is. I'll show you that in a second. Here's a 22 gallons per minute. See, we're using a bigger pipe for that. Now, this will make more sense. How to calculate pressure loss. You look at this. These are spaced 15 feet apart. So here's the math. If we have 12 gallons per minute total, that's going to equal 4.62 PSI that we were looking at for every 100 feet of pipe. But we don't have 100 feet of pipe here. We have 15 feet. So how do we figure that out? Well, I took calculus, but you know, I think I've forgotten most of that. And you don't need calculus to do this. These are fairly simple calculations. Or you can just get them on Google and they'll figure it out for you. But here's 15 feet of pipe. So 15 feet, we want to figure out what the 100-foot amount is. So we're going to basically take the 0.15. You just put a decimal behind the 15% loss for 15 feet of pipe times the times the 4.62 PSI loss, and you'll end up with 0.693. Now that's less than 1 PSI loss. To give you an idea how low that is, a typical system runs, starts at usually about 50 PSI, somewhere in there. So this is really low, but that's just for this section. So what if, and I'm looking at another one, probably skip past this, I don't think we really need it. Here's another one. So if we had the 15-foot section and we have 3 lines, these are the PVC lines, right? Got 3 of them, and there's the heads. And we're saying we have 12 gallons per minute. Then you add the 15, and you add another 15. And what do you end up with? It's basically just simple addition. You lose 2 pounds of pressure through all this, okay? So that's one. We'll give you a better example even than that. I didn't show the, I don't think I was showing that one, how that one worked. Okay.
Do they have any questions maybe? I wonder if there's questions or some kind of, you know, if they need clarifications. No? I guess not.
We'll get to that part. We'll get there. So here's another thing, and this goes back to what Denny was saying. You need to know the gallons per minute for each head. So you got to know what the heads are putting out. Like if there's, is it a quarter? Is it a half? Is it a 270 or is it a 360? Then you also have to know what pressure. The higher the pressure, usually the more flow I always try to stick in 30. So if we use the pressure regulated head, we know exactly what we're going to get. So this is a 15-foot radius, and the flow is, let's do them all. Okay, I'll move down here and apologize. So the quarter head starts off 30 PSI, 15-foot radius. That's only one, that's got about a gallon per minute. So I'm just rounding it. Then you go up to the half, it's basically double. So that's about 2 gallons per minute. We're not going to use any of the arcs. These don't always get used, but you could use them. But what we're going to actually be doing in the living room area is you'll get a better idea. It'll keep that fairly simple. You see on here, look at this, the circle head or the 360 is 3.7, and we're going to call that 4 gallons. So it's, you can sort of see the math here that quarters 1 gallon per minute, something double the size of the quarter is 2, something double the size of the half is 4. That's usually how.
I just wanted to say, because sometimes I teach also hydrology myself, and I mean, the students should understand that there's assumptions being made here and approximations. Hydrology is not like an exact science. You know,
Right.
So that's why you're approximating to the highest number, because it's an even number, easier to work with, and it still sort of fits the parameters. But there's a little bit of approximation that is natural.
Yes.
Yeah.
Totally, that completely makes sense. That's exactly it. And again, this gives another reason why you want to control those numbers as much as you can. Makes it easy. You can always, a lot of times they'll apply a 10% factor and make everything 10%, just call it larger, whether it be the pipe or maybe the type of nozzle. That's another thing too. But if you're not within the parameters, you could have a lot of overspray onto your sidewalks, things like that. What a lot don't realize, they're like, well, we can just adjust those down. But yeah, you adjust them down 25%. Yes, you can. Will it mess up the precipitation? Yes, it will. So you want to be as accurate as you possibly can. I know some designers, well, and I did this too, I would actually start designing shapes that would fit the irrigation that I was going to be drawing. That's the way it used to be done, more so than it is today, because now with drip, you can pretty much do any shape and not overspray. So there's a lot of pros to that. But this is where we need to start, because this is the basics of irrigation. When you get to drip, we have a lot of nice cheat sheets, so you don't have to do all this. So, and it's worth it. I mean, manufacturers has the data to do that. So here's head-to-head coverage, and what that means, these are all heads. Okay, this is a tough shape to work with. I know you guys design a lot of tough shapes, difficult shapes, but you can see on here what this dotted line is. It basically means that the water goes from this head to that head. That's head-to-head. Pretty basic. Not totally basic. It's not always that easy to get something this perfect. You'll see areas in here that get overwatering. So sometimes that takes some extra adjustment to get that done, extra heads, whatever that is. And you'll see here, this is a bigger area, so they went with 15-foot radius heads, and here they went with 12-foot because it's smaller. And we also want the water to travel from one head to another and back the other way. That's the way they're calced in the lab. They're calced to be even amount of water when you throw the water head to head. If you don't, and let's say this was a half, you'd have no water here, except from the one head. And that's not enough. You're basically going to get dry spots in areas, and the other areas be too wet. So head-to-head coverage, and it's a lot easier now to do because you're doing everything. This guy, whoever drew this, didn't do it obviously on AutoCAD or LandFX or any of the other software. So that can figure out a lot for you. Here we go too on the same thing, but these actually have the GPM. Denny, that's what you were talking about. It is, you do have to have all this on there, and you also need to know roughly what that pressure is going to be. So that has that. And then here, we will do an example of this. This is a layout. There's a lot of ways to do these layouts, but believe it or not, depending on how you lay it out, can save a contractor, developer, dollars. And the reason that is because if you do this in a different manner, and we'll show you down below, if you do it in a different manner, you can have bigger pipe sizing because you're having to carry more of a load or more water to make everything happen and have the minimum friction loss as possible. So we'll show you why that is. This is one layout. It's not too bad. It's obviously a very small system. There's not a lot of flow in here. So we're going to move, and actually we're going to go to previous that, and bear with me, this should work just fine, but you never know. Oh yeah, there we go. Ah. Okay, can you guys see Fernando okay? All
Yes.
right. So here's the deal. First time ever done in the United States. No, I don't know about that. And Norway.
Awesome. I never seen it done. Actually. Great.
Well, we haven't done it yet, so we'll have to see. We did a couple run throughs just in case. So this is my. Can you guys see my mouse? Okay.
Your what?
You see my mouse?
Your mouse?
I'm sorry. Do you see my cursor?
Not
It's
sure. I can't.
Maybe not. I don't think it works like that, but it's okay. I've got Fernando do this. So what we're going to do is we're actually going to build a system from scratch. All the edges, if you see down toward the bottom of your screen, those boxes would just assume that that's an edge, like an edge for, let's just do grass, even though a lot of people don't use grass anymore, but let's just do turf on this one. And then if you look behind Fernando, there's a lot of boxes, that's another edge, and then there's a furniture as an edge. So we pretty much have a rectangle, might be a little bit different than that. So here's what we're going to do. We're going to see if we can get Fernando to do all this stuff. So
okay, so guys, this is going to represent our controller over here.
First, can you hear him okay?
Yeah, how's the sound working, guys?
Kenny, can you hear him? I'm sorry.
Yes.
Yes?
It's good?
You can hear him okay? Awesome. Thank you.
All right, awesome. Thanks, guys. So this is going to represent our controller over here. And I'm going to go ahead and set this down right here. And remember, this is going to be the brain of our system that's going to basically run. And this is an actual controller. This is an outdoor model. They make them indoor as well. One of our flagship ones. This one goes up to 22 stations. Just a very good controller that's easy to use. And you can also has internet capability, so you could use it on your phone as well. But that's going to be our representation right here. I'm going to control it.
So the controller is typically going to be placed on a wall, probably, or maybe in a pedestal mount. But in this case, we're just going to pretend it's a wall.
All right, now we're going to go to, these are going to represent our corners over here, cornered spray bodies. So that would look like this is a 4-inch pop-up. And the reason we call them a pop-up is because they pop up, right? But it has right now an R-band nozzle, the rotary nozzle that we were looking at earlier, that's all hand adjustable. So this one is just there for show, but we're going to represent a corner nozzle with these guys. So we're going to go ahead and put these on each corner.
So just so you guys know, these hats were all bought and intended for your class. So normally what I do is each one of those would be a person and they would be a certain flow rate. So we'll talk about that, but the quarters basically in this case were going to be 2 gallons per minute. The 180 degree or half circle was going to be 4 gallons per minute, and then the center head would be a total of 8 gallons per minute. So that's why they're different symbols, and we're going to see if he can do it right.
This is the
So-
center head right here.
You got that? You figured that out? Because there's only one. Maybe that's how I figured that out.
Yeah.
So he's just sort of laying them out at random, and of course, the quarter heads are a little easier to figure out. But I will get him to go ahead. Tell him what that is.
Because this is going to represent our valve here, which we have. Where did that leave that? To show you guys how a valve looks. Right here. So this will open and close based on what the controller scheduling says. And the way it does it is it has a little solenoid in there that pulls up a plunger, and it switches the force inside of it to go ahead and open a diaphragm and allow flow to happen. So that's what this little baby is going to be representing. It's going to be hooked up to our controller right here. And these are the two wires that we have just to simulate actual wires, but we'll put the valve right there. Then these guys are the halves. So our little alpha guys will represent the halves. So we'll have our quarters, and then we'll have the halves. So here. And I put the placement a little bit wrong because I put this one right here. This is a
Yeah, you
quarter.
better fix that quarter.
Yeah, exactly. So there's our half, right, with our sharp edge, and then I've got the other corner here. So that's all of the representations that we have.
So how do you get those spaced correctly? How do you get those spaced correctly like that? Like your center head. That one in the center.
Oh yeah, it's not too center. Our head-to-head coverage, is that what we're talking about?
Yeah, the head-to-head or that
Yeah.
piece of string you have there.
And that would be represented right here. We have, this would be the full circle, right guys? So since we want to get head-to-head coverage, we just are representing that with a string right here. And it's almost, if you could see, covers all the way around.
So if it wasn't in the center and you're doing this on a CAD drawing, it's very easy to just, obviously drop it in the center of that area. And you can also have the radiuses. Now, just so you know, there's a lot of programs like LandFX is one of them. I'm not trying to sell their product, but they have a great program that will do all of this for you. All you pretty much have to do is say what head you want, what area, and it lays out the pipe and everything for you. So sometimes I think we get intimidated by irrigation, but with the kind of programs and it's developed over the past maybe 12 years or so, it's incredible where a lot of landscape architectural design offices are actually bringing that work in-house instead of subbing it out.
Mhm.
Yes, sir. So next off, we were going to first give you a bad example of how you would lay out your piping. Because there's a lot of ways there's probably, 4 or 5 different ways you could lay this out, but there's definitely one bad way. So maybe that we'll show you, maybe start one of those strings from the valve. So again, the valve is what's getting turned on and off. So that's going to have to go into that PVC pipe we were talking about. Now, what Fernando's doing right here is he's figuring, he cheated a little bit. He already has a piece out there. But yeah, it's all right though. You're good. I'd leave that. So if he wants to go this way, so far we're pretty good as far as head layout, and I can tell you why. But if he keeps going around and down that side, this might be harder than actually doing PVC pipe. But all the way, yeah, exactly. So you can just tuck that one to your, yeah, that should go all the way to the valve.
To the valve.
Yeah.
Just,
That's perfect. Perfect. We're just going to make him do it all over again. This is where he gets an exercise.
Exactly. There we go.
So there we go. That's one way. Now, Now, I would normally ask is, why is this not a good way to do it? It will work. It definitely will work. But what's going to end up happening where he's standing now and where he's facing, yeah, straight forward from you. Yeah, there you go. Perfect. That area is going to have the smaller pipe size, but as you go all the way around, you're going to be picking up flow rate. So all of a sudden you're going to go 2, 4, which is 6, and then you're going to have another 2, which is 8, and then you're going to go around another 2, which is 10. All of a sudden you're in a bigger pipe size. So you get larger and larger pipe size, plus trenching is very difficult to do like this in a big U shape, but believe me, people do it. And a lot of times when they do this, they'll just say, okay, 3/4 inch pipe is fine. That's adequate to do it. And then they find out that they have to add another valve, to make the system work, or they change the heads themselves, or they repipe it. So we're going to show you the right way to do it. At least it's the way we think. We're going to use different, you might want to pick up the string that's already down there that you got. Just throw it into a wad. You don't need to roll it up.
This guy?
Yeah. Just give it all that stuff.
All of it.
Yeah. Won't be confusing. So we're going to use different colored string. And the reason we're using different colored string is for different size of pipe. And again, you're not looking at the chart or anything right now, and you could be, but you really won't need to on this one. A lot of the rough flow rates I have in my head, and you'll find out there's not that many, really. So if he can, what we're going to do is, Fernando, why don't we start on the farthest away from the farthest away. Now, irrigation's a little different. You're actually going to sort of work backwards. You're going to do your head layout like we did. We've got the right nozzles, which we did. We know where our controller is and our valve is. Very important, because we'll know how to lay out the piping. Well, in this case, what color is that? Purple?
Purple.
So if we go just simply from that, a quarter head is 2 gallons per minute, a half is 4. In this case, that's 6 gallons per minute. Once you hit 6, you're at 3/4 inch pipe. Now, you typically, I'm going to rule something out. 1/2 inch pipe, just do not use it. Over a period of time, people used to use 1/2 inch pipe for lower flow, lower cost, but what they find is every time they have to go up another size of piping, they have to use special fittings. It actually costs them more than using all the same level pipe. So all I'm saying is, don't start at 1/2 inch, start at 3/4 inch. So the 3/4 inch will actually cover all that. Now he's going to take a piece of string and go to the tree in the middle, which is our full circle, which we're putting that at 8 gallons a minute. Now watch what happens. At 8 gallons a minute, we have to have a 3/4 inch pipe minimum. But if you add those 3 heads, see those 3 heads are all connected right now. So now you add them all together. What do we got, Fernando? How do you do math?
Well, if we're doing the quarter, that's 2.
Yep.
Halves are 4. We got 6. And then when we go to a full, which will be 4, we're looking at 12.
12. So we got 12 gallons. So now we got to move up to a 1 inch pipe because of friction loss, right? So
Right.
friction loss, and actually it's almost getting up to 1 1/4 inches. Somewhere in there, it's right on the borderline. So right now we're just going to use a 1 inch.
And that'll be our green line, right?
Yes. And then, so once we have that, now you got to add that to that, everything else that's upstream, so to speak. So now what do we have?
We have more of our.
No, I'm sorry. So what do we have as far as GPM?
Well, we got 12 with those 2, and then we're adding another quarter, so that's 14.
14. So yeah, once you get up there, now we're probably at 1 1/4 inches, and that would be another color of string that would go from that little area. A lot will cheat on this, but you just need to do what the hydraulics are going to tell you to do. Now, on the other side, it's a little different situation because we only have a total of 6, and then the 6, and then the end one is another, 2?
2.
So that's 8. So we could pretty much do that whole side in one color of string. which is, again, this would be a little bit more fun if everybody had a hat on right now, but we will do that next time. It just makes it a little more interactive. Once you're doing it, you're like, okay, I was the quarter head, and you'll remember you were 2 gallons a minute in this case. Now, the quarter could be anything, right? It could be 1 gallon if it was a big rotor. It could be 10 gallons a minute. And it's no different if you could picture yourself spraying, if you were that quarter head, you're looking at 2 gallons of water you're going to put down in a minute. Okay, and that's going to be across the entire area. Remember we showed you the head-to-head coverage? That's going to be that whole piece. So, so hopefully, there you go. That's another way to do it too. But Terry's doing a little bit of the radius, taking a string off there. And some will do this in the field if they don't have an irrigation plan. They may just do something like this. So here you have everything. The only thing we don't have here is the backflow preventer and the water meter. I don't know, maybe we'll get that next time, maybe. You have any other comments, Fernando? Are we good?
Yeah, no, that's good to go, guys. Thank you.
Okay, move on to the next. Any questions with, let's see.
Yeah, from the students,
That makes sense?
2 people join. Yeah, especially to be able to see it helps a lot visually.
Yeah, exactly.
That's good. Yeah. And I think on part of it, let's see. You still see that. So
The backflow.
it's always tricky things. Somewhat tricky. Lots of sharing. Okay, let's try this. You guys see that? No?
Yep. Can you?
It didn't come on, I don't think. Hold on one sec. All right.
Hey, Mike, how you doing? Good, good.
Huh. Sorry, one second. I'm just trying to get this to change over.
In the meantime, if they can think of any questions or anything that's unclear, we can revisit it.
Good idea. Huh.
No.
So strange. We'll only do the keeps the webcam, but it's not sharing. Maybe I'll go to that. Try that first. No. Uh, sorry, guys. I don't know why.
Is it the engine?
What's that?
The engine or something? You have to click engine.
Where are you looking?
Oh, never mind. I thought I saw it, but let's see. I'll log on myself and see what.
Hmm. Yeah, you're logged on. I see what he sees right here,
Yeah, it's showing.
but it's not letting me stop sharing. I don't want to have to start up the whole thing again. Let's do this. Still the same, huh?
I was doing it for.
I don't know, Danny. It's very strange.
I'm not quite sure how to.
No,
Sorry.
probably not, probably not on this one.
Certainly, you're asking the technology to do a lot of things today. So
Yeah, that's true.
You're right. Oh, come on.
it's good. It's always good to give a break anyway. So this is the.
It's been an hour or so, right? So, yeah, it has. Then break time, that's it.
You can come back in a few minutes if you want. No? Do you need to log off or do anything?
You know, I thought about that, except I've got a bunch of, I guess it wouldn't matter.
I don't know if you're gonna lose us or if you log off.
Yeah. Huh. Hmm. Well, guess I could do that. Log out and log in. Right now, you see the same thing, Dave?
I see part of a PowerPoint.
Oh, you do? We did
Yeah.
it. That's what I needed.
Okay.
I think you fixed it, Danny.
Oh, great. I'm glad that I did so good.
It's ridiculous. I have no idea. Did the same thing every time, but it's okay. Thanks for patience. Okay, this just shows some different controllers. Fernando already lifted up the one, but this on the left is becoming more obsolete with at least with our company. This is weather station. Pretty much does everything right in here. It even catches rain and evapotranspiration rate. And then this one here, you talked about, you can actually hook it up to your phone. Super nice. We have free apps on the phone, and what they'll do is you can set it up on the weather settings. So if you put 30 minutes and you only need 15, it reduces it automatically according to the weather of your zip code. So we've done that even on a simple, inexpensive unit, relatively inexpensive. It depends on who you are, but we do it on a lot of front yard landscaping you see in developments because it's easy to use. It hooks up all to your Wi-Fi, and then again it adjusts, and that helps a lot. It takes a lot of the brain work out of it. This also shows a moisture sensor. We do have one, so it will figure out how much moisture is in the soil, and then you can adjust it up or down. Once you have it dialed in, it will only let the controller irrigate when it needs it. So moisture sensor, those have come a long way. I still think Rainbird needs to do a lot more with moisture sensing. I'm a pretty heavy believer in it because I've done a lot of drip irrigation. Seems to be a good way to go. This is a TM2. This is the one we use for the tract homes. But if you flip this open, it's very easy to use. Once you have it on your phone, you won't even use this at all. I very rarely do anything with that.
No.
This might look a little different to you, but these are screenshots off my TM2. So it'll tell you when the next irrigation time is. It will tell you what the forecast is for that particular day. And then all these other features, including you can shut off rain for 14 days. I just threw this picture on there for the heck of it. That's not my yard. But you can actually throw a photo in here of your yard or your garden, so that way you know what area for what program to run that in. So that's nice. I think we need more places for more photos because, you know, there's a lot of different areas. There's pots and there's roses and trees and lawn, and, you know, all we have is we can do 3 pictures. Better than not having it. And then you can just click these on or off, what days of the week you want to water. Here's seasonal adjustment. You can do that manually, or you can do automatic. So this is just nice. It's very easy to use. It's, you know, this was off my Apple phone. And you look on here. Forgot what school. This might be. I don't know. Thought it was Davis.
It almost looks like
I think it's Davis, but
I recognize that.
that's coincidental that that got on there. And obviously,
Mark, if you look at the chat, there's a couple of questions. I don't know if, or there's at least one question.
I'm not. I'll have to get on. Sorry. Okay, here. Can it not do a photo for each zone? Says, can it not do a photo for each zone? And it can do it for each program, but no, not for each zone. So I'm with you on that one. It'd be nice to have it. Does zone mean plant hardiness zone? Could mean plant hardiness zone. But in this case, it's not like a high, medium, or low water use area. Zone is like, could be a station like we showed just a minute ago at a valve. That would be a single zone, or it could be a single station, or it could be a single valve. That does make it a little more difficult probably than it needs to be, but, and then I,
Just a zone in the project, in the project area, no?
yeah, the project
A
area.
part,
Yeah.
a part of the project is the zone. Yeah.
Yes, yes. Oh, yeah, and then, yeah, there's also different exposures is another thing. It's not necessarily called the zone, but there's whether it's northeast or southwest, or you do them individually, all that's important to irrigation. That's why we're not getting into everything, but we're getting into a lot. So, and thanks for all those notes. I put your screen flash for a second there. That might have been, what time was that? Doesn't say. Okay, so you can also see there's a calendar on here. And the calendar will actually list everything like you would on an Outlook calendar. So it's sort of nice. That's a lot for a little controller.
Yeah,
It used to take a controller that was like, you know, $2,000 or $3,000 to do those functions. And to have everything free is great. I'm going to go through a couple other things. This looks like a lot tedious, but we do have online, we have legends that are already pre-built for you. The nice thing, see this area in green where it says product line? You could click on that like you're like, I don't know what that means. And this is where it goes to on the website. It takes you right to the product that you're looking at using, or this is a pump, that's another one too. It's real handy. Drip, wanted to get to that. It's a whole different thing to design with drip than it is with spray. I'm not going to say it's necessarily easier, but when it comes to calcs and everything, we've done most of those for you, so you won't have to do them. You still need to understand, like everybody always says, you need to understand how everything works, but I found that many, when they see the whole spray thing, they get a little bit, it gets to be a little bit much. And then when they look at drip, they're like, oh, I think I'll just do everything drip from now on. So sort of where it goes. So you can see Rainbird has the biggest array of drip emission devices. Some are called point source that look like this. Some are called, these are N-line. This is just a 1/4 inch N-line. You can see stakes with an emitter on the end. This looks like a little flying saucer. That's our Zero Bird. So there's all different types. It's selecting the right type is probably the most difficult part. This gives you a better visual of the two main types that I see and that you'll probably see. This is called drip line. There's an emitter inside here. You don't have to put it in. This one, you have to puncture the tubing, run tubing. This is a bug cap through a stake. All these pieces instead of just this. Up to you. I prefer this. But, you know, some like this. They like seeing more of the water. And they think they waste less. So than they do at the drip line. So these are emitters every 12 or 18 inches on center, and they come in different flow rates. All right, so hopefully I have this. So hopefully it'll be easier to get to than before. And I will. This is a guy's named Andy Bassett, and he's in Alaska. And he's actually lived off the grid for 30 years. Now you wonder why I put him on there. He's got a garden in there let's see, 80% of his food is produced from one greenhouse. And the greenhouse was all watered by hand. He pumps in the water from the Yukon, pumps it up to these two big containers up here. and he uses that for his pressure, and then he would water everything by hand. So off the grid 30 years, this guy knows what he's doing with a lot of things. So what I did was, well, what he did actually, he asked for some help. He sent a thing into Rainbird and then ended up, it's all right. Is that very loud on you guys? Can you guys hear that background noise? Is it all right? Oh, maybe. It could be worse. Anyway, so this guy, he was asking for help, not necessarily for product, and then I got the project, and then we went ahead and I worked with his plan and with him just over Skype until he built his garden. I asked him, this is National Geographic, Life Below Zero is a regular show. He said, I said, will we get much on televised? He said, oh, I don't know, maybe 30 seconds or a minute. I'm like, hey, could you make me a video? And so he made this video, which worked out really well. Seems like a lot of people like it. So if I go to new share, we'll try to do this again. You guys see anything? Yeah? Okay. Can you guys hear that?
Can't hear very well. You might need to lower the volume or to raise the volume.
Yeah, I think I can raise it.
Out here on the Yukon River, about 120 miles south of the Arctic Circle at my homestead, Calico Bluff. And I've just started working on a Rainbird irrigation system for my newly refurbished greenhouse growing operation. I have a kind of a unique system here. I don't have running water. I live off grid, and I get all my power through the sun and through the wind. So a little bit challenging to run just regular irrigation. I either have to run pumps or hopefully gravity feed. We're going to find out in a little bit. So one of the unique things about the way I do things here is I have to get river water from the Yukon River. I pump it up into these two large holding tanks. The Yukon River water is extremely silty, so I have to let that water kind of settle. And what I've done is I've connected these two tanks. I have a low point here where hopefully some of that silt will be able to settle down to. I can purge that system right here, dump a little bit of the silt, and then the primary water feed comes out of here, goes into this very efficient Rainbird filter here. And once it goes through this, hopefully it'll be very, very clean water, no particles to clog my emitters later on. I've got all my dogs running loose. So from that point there, I go through this filter that cleans the water, then I go down and I've got an AC pump right here. And I'll take you on a little tour of what I've accomplished to this point. Here are the holding tanks that I use when I'm pumping Yukon River water. Each one of these tanks hold about 350 gallons, 375 gallons of water. So the purpose of this is to try and reduce my water consumption by only watering the plants, not watering a lot of the dirt and soil in between the plants. I'm out of my tanks right here. I go down through this filter. This is going to hopefully clear out any debris. It's a mesh filter, and it should take out quite a bit of the silt, fine silt. Then I run this 1-inch flexible pipe down into this little AC pump right here. So I have my hose coming in, my hose going out, and that goes into this very nice manifold system that I just built. And we're going to take a trip inside the greenhouse and see the rest of the plumbing. So one of the challenges that I have living out here is later in the season, I do have nights where it goes a little bit below freezing. I have to worry about pipes freezing. And that's why I use a lot of this flexible pipe. And I've also created this coupling right here so that I can take this system apart very easily. I can undo this and then pull the entire manifold out and put it if I need to. so we're inside the greenhouse now. You can see I've got 6 zones on this manifold, and it seems to be working pretty good. I also have these filters here made by Rainbird. These are a screen mesh filter. So I have my water coming in through here. It goes through a ball valve, so I can turn it off on or off right here. And then this filter not only filters the water, but it also reduces the pressure. So the pump that I have will be pumped at about 65 psi. I need to drop that way down. This will take it down to 40 or a little bit below 40. And it also acts as a mesh filter. So what I did is that before I got the whole system going, I took this apart, took the filters out, flushed it out a little bit, put my filter back in. So do that on good and tight so it doesn't leak, and you want this to be in line with your lines as best you can. Mine don't go exactly that way. This is a line that's going to water some beds outside the greenhouse. But I've got 6, so you can see here, there's one for beans, there's one for tomatoes on one side of the greenhouse, then there's an outside one, there's another outside one there, and I have tomatoes and pepper plants. Okay, so there's my manifold. You can see what I'm doing here is I'm actually running the pipe up vertically, and then I'm running it all along the tops of the greenhouse. The reason for that is that this greenhouse is designed to take the end panel walls off and be able to run my tractor through here with the tiller on it. So I can take these walls off. Each wall has 2 panels. I can take those off with 3 or 4 screws, remove those panels, hook up the tiller on my tractor, run through here in the fall time to till this all up, and then go through in the spring before planting. So traveling up here, you can see that I'm running vertically and then horizontally along the eaves here. And the reason for that is obviously for running the tractor through here. But it's also to keep the water lines up high like this so that I can feed these pepper plants. So one of the unique things that I do is I grow my pepper plants upside down. And I basically run the lines over here. There's an emitter right there. That's a ½ gallon per hour emitter, blue one. And I have this line here. It comes over and then feeds right into the pot right here. Okay, so I've turned on the system for the peppers. And as you can see right here, I grow my peppers upside down. And that's one of the reasons why I'm running these lines up high like this. You can see I've got an emitter right here. It's a ½ gallon per hour emitter. Goes into a small feed tube and then into the Rainbird system for mounting. And this is a little holder right here. There's a little arrow on that. You definitely want to make sure that the pipe's going in that direction. And then this little thing to keep the bugs from going back up your line. But you can see right now I have no pumps running and I'm working off of just gravity feed. And I'm going to be obviously putting a ½ gallon per hour into these pepper plants right now. So I'm really, really excited about the fact that all of this is going to work and I don't have to turn on any pumps. So a perfect system for a person who wants to do a off-grid system with no power. So you got to get your water storage up high. Once you have your water storage up high, you're good to go. I'm really excited. You can see these pepper plants are kind of interesting. They grow out of the bottom of the pot and they very quickly turn and start growing vertically. And that's just going to give them more room to grow up before they hit the ceiling here. So I just turned on the emitters for the tomato beds and the zucchini beds. And as you can see, even with just gravity feed right here, this emitter is working perfectly, just like it has pressure on it. So right now, the way this system is set up, I'm able to water my entire greenhouse without ever having to turn on a pump or use any electricity. The only thing I have to do is probably cost me about a pint of gasoline to pump the 700 gallons of water up into the holding tank. So this is actually a really interesting operation, a really interesting design that would work for anybody living in a third world country, living off grid, living where running power electricity would be a challenge, and very efficient. Okay, so what I'm going to do here is is in this one that's got the built-in emitters. I'm just going to go ahead and add a small emitter right here. Oh, look at that. There's water coming out. Because I've got that valve on right now. Look at that. So that's a 1/2 gallon per hour emitter. And that looks like it's going to work just perfectly now off the gravity feed. So I'll just put a couple more of those in. I think what I'll do is just put those in on either side of the regular emitters. And then if I feel like I need more water flow, I could always turn on my pump, and I would also have water flowing right here out of this emitter. And as you can see, the water's flowing just fine out of these 1/2 gallon per hour emitters. I'm just going to add those in, and then my entire greenhouse will work perfectly well off this gravity feed system.
That's great. That's pretty cool. You got GoPros all over the place.
Okay, so the other thing I've got in each one of these systems, you can see this is a 3-line system here, and you need to be able to get air out of it. It'll purge the air through the emitters, but I want to be able to purge sediment or really blow these lines out from time to time. And so what I've done is I've added a ball valve here, and by turning on that ball valve, I can purge the air, and I can also clean the silt out. And if I wanted to, these are all threaded. I'd be able to set it up to where I could put a hose on any one of these if I had some additional things I needed to water. Okay, I'm all done with my installation of this Rainbird irrigation system. About a day and a half. Everything's working great, easy to put together, really intuitive system. Everything fit together well. The tools, specialty tools work well. And I'm really stoked because it's all working off of gravity feed, so there's no power needed, no pumps, anything. The system design, running everything up high, bringing it down, is working just the way I hoped it would. I have a backup pump just in case, but so far I'm not needing it. Everything is working perfectly well. So really excited. Tomato plants, squash, cucumbers, green beans, everything's getting water only at the plant. It's going to be really efficient for the use of water, and hopefully it'll be really good for the production. I'm going to keep everything moist. I'm excited to have a really high production greenhouse. I'll check back with you later on in the summer as time progresses to show you the benefits.
Here we are.
It's a very neat greenhouse. It's a drive-through greenhouse.
All right, can you see?
Yes, that was interesting. Yeah, the use of gravity is very, very smart.
What was interesting to me is he honestly does not have enough pressure. He's not using his pump because he had a solar system, but there's not enough to honestly run the system, but he made it work. That's sort of because those tanks aren't high enough. So, but it worked. So, but you know what didn't work, which I noticed actually watching it this time, was the inline emitters didn't open up because they take 15 psi to open. So his pressure is probably a little less than 10, I'm guessing. I got a question. Thanks for the diagram of irrigation layout. That was super helpful. I was wondering what is the appropriate use for the pop-up spray versus drip irrigation? What kind of project would you not want to specify drip irrigation? Good question. There's a lot to that, but I would say most do not know how to use drip irrigation in turf areas or subsurface lawn. So many times I don't, but I mean, we in general avoid that. So we go with spray or with rotors. Now, when you have like large areas of turf, I can tell you this much, Most areas in California are done with sprayer rotors when you talk about sports fields. But if you go to Colorado, that's not the case. There's actually a lot of people there that actually know how to use drip under turf, and they don't have any problems with that as far as picking flow rate or anything else. So, but you can do almost anything with drip that you do with spray. But sometimes it becomes cost prohibitive if it's not done right. So that's a good question.
But in general, it's sort of, you would want to use drip when there's a lot of hardscape or these, you know, on irregular areas or, right? I mean, because if you have, even if you don't have turf, you have a lot of planting areas, but these planters have irregular shapes. That's going to be very hard to sort of achieve with the pop-up, you know, kind of the sprinkler. It would be the drip irrigation would be most appropriate.
It could be. In most cases, I do have a couple other videos in here too that will help with that, because I always struggle with trying to teach something without actually building it, especially when it comes to subsurface drip, like say under lawn. With tricky areas, we got to go around stones and pools and walls, but you have to know how to do it, and you have to know how to do it correctly for that, you know, for that to actually work. But you're right. It's funny. You go to different regions. Like if I took you to the Bellagio in Vegas, you're thinking, well, you know, they don't have much grass, but the villas where the people that are paying 15 grand a night, those are pretty nice, but they actually water all their lawns with subsurface drip under turf, and all the shrub areas are all subsurface drip. Now, what some of them do is they'll actually run a secondary system if they're not confident in overspraying for seeding. That could be the case, but you know, it's like anything else. You can get pretty good at it, and you can, you know, space the drippers, you know, 18 inches apart, even further sometimes. So but it's a good point. That's what most will think until you get into a different region. It's another reason I actually included, if we can get through them, I included some good examples of very large areas and very small areas with the equipment that it takes to put it in. So it gives, because if you don't have the know-how to do it, you're not going to do drip in big areas because it's going to be cost prohibitive, because there's so much plastic and so much resin compared to doing a few spray heads or a few rotors. But yeah, it's interesting. I mean, I love that part of it. That is a challenge. Somebody put here, probably subsurface drip has been proven to work the most efficiently on lawns, has it not? Plus, it would help with the AB 1881 specifications that have to be met, wouldn't it? Totally true, except just as much water sometimes is wasted by drip as by spray, because again, a lot don't know how to select the correct product. So they're selecting high flow emitters. Like for instance, a gallon per hour is a high flow emitter because you have so many of them. But if you spec something half of that, then you can be efficient and you won't waste as much water or runoff, because some drip systems put out more water than a spray system. And a lot of them don't realize that. So that can be a big waste. And you're right about the AB 1881. As far as legislation goes, it's huge. A lot of offices have had to go to drip just because of that. So that way they meet their minimums. So when you said, when you say gallon per hour, you mean 0.9? Yes. There's somebody that knows too much right there. I'll have to put them in the advanced class. Because, yeah, the 0.9, yes. A lot of the high flow rates are 0.9, some are 1.0, and then it goes down 0.6, 0.4, and 0.26. 0.4 is like the sweet spot, but if you ask most of the people, they would tell you I'm lying. So don't ask, just use a 0.4 because it's the infiltration rate of soil when you have clay soil is very slow. So if you put down a 0.9 in clay soil, the water, instead of spreading laterally through the soil, it will go straight to the surface and just flood.
And we've
So-
seen that, yeah, definitely. Especially in the Bay Area, we have a lot of clay soil, so we encounter those types of problems out there in the field.
Good stuff. So I'm going to whip through this. Can you guys see everything? The PowerPoint?
Yeah.
Okay, great. So these are all the components that it takes to put together a drip system, or actually put together a good drip system. This is the actual inline tubing you see. This is has a valve. The filter you saw in the video, and actually the little dot, that's where the regulator is. So you can't have high pressure in most drip systems. You should be 50 PSI or less, and these are 40 PSI regulators. This is something we have headers, supply and exhaust headers, and this you'll see later, I'll show you. These are already pre-done, so all the fittings are on here. You just attach this tubing to that fitting. It's very fast, and you'll see some examples. These are our fittings, or special fittings made to work with a special tool. And these are another type of fitting called twist lock. And this is an indicator stake. And what that does is that indicates that the system's on. Another difficult thing with drip that this really solved is whenever your system's on, I use them, you know that it's working without having to put a moisture meter or something else down there. I'm not going to go through a lot of the promo thing, but we have a couple different types of drip. We have it with copper. So we'll have a copper chip, and I'll show you what that looks like. And the chip, what that does is it keeps roots from growing into the emitters themselves, which can clog. It's a common problem. Rainbird came up with this in 1999. It's been around a little while. Nobody else has been able to break that patent and do copper chip like pure copper. And then the CV, this stands for check valve. And check valves, again, we talked about that earlier, are huge. Our new product, the XFS CV, it actually can do all these situations. You can bury it, you can put it on slope, you can put it on surface. So, you know, it's nice when you can do all those. You don't worry about roots. If you put it on a slope, you can go up 10 feet. And every emitter, when you shut off the system, will shut off at the exact same time, so you don't have any waterways or erosion. Now, if I go to this, let's see. Guess I gotta do that. See all kinds of fun videos, except I don't see the. All right, you guys see that okay? I think so. All right, here's a video. See, I like to make a lot of displays, and the reason is it's tough to convince people sometimes until you actually build it. Plus, it convinces me that it really does work, even though manufactured we have all the information on there. But this actually does work. So turn this on. Circle of death. Right. I don't know if anybody's on. This is our train. Angular slope ripple line display. What we're going to do is complete the comparison between the XFS check valve. XFS working product is not a check valve. We're going to turn on the system. Now, operation indicator state, so we have at least 20 PSI. When we run all. Get rid of that window. Yeah, this is check. No. Valve. Yeah. Oh, yeah. So check water up to 10 feet. Herky jerky. Not the way I made it. Every emitter will go off at the same time when the system pressurizes and turns on. Can you guys hear me okay? Oh. Thanks. I thought the video was a little bit choppy for whatever reason. It's not on YouTube. I'll try it one more time, but if not, I can explain it. This side does not have a check valve. It will continue to drain until the water is completely out of the dripper line. So what I'll do is I will turn this off. Again, this is a fairly short demo. You see right now everything continues to run. They're all at 0.6 gallons per hour emitters. And there's 3 per drip line on each elevation. The operation indicator statement shows there's still pressure in the line, probably about 20 psi. So until that lowers, things will continue to run or the pressure reduces. We'll take a look at the check valve side. I already see that the emitters are shutting off. In fact, all of them at the same time. The same amount of water in every cup. So we'll go to the other side now that the operation indicator state has completely gone down. And we'll see that on the top, the water's pretty much stopped. On the middle row, you'll see it's still running. And then on the base, it's running also. Each cup, after a period of 10 to 20 minutes, will have a different amount of water. The least amount on the top row and the most on the base. And you can already see, even though these have the same flow rate, each dripper line, you can see that the non-check valve versus the check valve are different amounts of water. So what are the advantages here? One, with XFSCB, a check valve product, you do not have low emitter drainage, which promotes better and more consistent plant growth and deters erosion. Or on the non-check valve side, it continues to drain, which means inconsistent watering and more water at the base or toe of the slope. Again, this is our triangular slope drip line display. Okay, hopefully you guys can see this again.
Yes, we can.
All right. The video's off.
Yes.
Thank you.
You can see your PowerPoint.
Okay, great. So I know we're getting close on time, but I'll go through a couple more things, and I'd like to get through get you that one video, see what you think on the sort of some of the differences between you'll see between the drip and the spray. But here's some of the different flow rates that we have: 0.4, 0.6, and 0.9. There's the spacing, that's typical spacing, 12 and 18. We don't do custom very often, but sometimes we will. If they're willing to buy 100,000 feet, they will. We will do that. And then coil size, there's different coil sizes depending on what's easiest for you. And we actually have copper color to show that we have a copper chip in the tubing, and then we have purple, and we have purple stripe. Both the purples are for reclaimed water purposes, but we use the purple stripe on top of the copper or the brown, and that makes it a little bit more aesthetically pleasing, which most of my designers prefer the purple stripe. But that's all agency required. Control zone kits, we have a lot of different ones, but the main thing to remember is valve filter regulator. This has an anti-siphon we talked about, so bad water doesn't come back into the house. This is actually my personal favorite for a lot of reasons. This is not a Y filter, it's a basket strainer. You saw in the video that this is pretty easy to open. You can service it from the top. For most of them, you got to service it from the side or underneath. There's also an indicator here, which is great. So if the water's dirty and you turn on the system, it will show red. If it's clean, it's green. You don't need to clean it. So also go to very low flow rate. So when you do, like you have a lot of larger zones, maybe 20 gallons a minute or something like that, but you have a zone of a few pots, lower flow, this is less than a gallon a minute. It's almost a third. So you can still, what that does, it allows the valve will actually shut down. If this is higher at 3 gallons a minute, but you're only outputting 0.3, the valve will not shut off. That could be a problem. Here's some design. I'll skip past this. Holds back 10 feet. This is sort of nice. You get an idea of what's in an emitter itself. You got the copper chip, and here's a diaphragm in there, and this is the part over here that operates the check valve. Let's see. Somebody asked a question, how many linear feet of PVC or drip line and heads or emitters went into the biggest project you've seen? What or where was the biggest project? It's a good question. One of them was the Wynn Resort in Las Vegas. I worked on that one. It's a pretty good project. Maybe the total project is about 100,000 linear feet of drip line. Another one, I'll show you just a snippet of, I don't know, it's less than a minute, man. I think it's like 10-second video of a project that I worked on some soccer fields in Edmonton in Canada. And that one was huge. There was 6 soccer fields, I think, total. Spray and rotors, you know, it's more of the big ones are ball fields, things like that, or parks. So if we come down here, you see operating pressure. Not a lot we really probably have to look at. Here's about the check valve again, copper shield. We talked about that, emitter spacing. It is UV resistant. A lot will ask, can I lay the drip line on the surface? And yes, you can, because there's ultraviolet inhibitors inside of the drip line. Actually, it's part of the actual tubing. And the purple stripes, we talked about that. This is a nice page. We have this online. You can literally go through this information, just ask you questions like, what are you going to irrigate? Ground cover? What kind of soil do you have? Is this a slope situation? How much area will be irrigated? What is the outlet pressure? And then you just press calculate, and it will calculate the type of drip line, the part number, the flow rate, the emitter spacing, the row spacing, which is the spacing between each drip line row, and then the recommended row spacing. And I'll also tell you how many staples, how many feet. I mean, it gets into quite a bit of detail, but I suggest that's a good one to sort of play around with. I don't know why I went to that, but oh well. You still see the, it went to that because it's the live link. Can you guys see a detail?
Yes, we can. I was going to
Perfect.
ask you if you could show some details.
Okay, I'm going to share some details. These I'm very passionate about, I have to say, only because at Rainbird, when I came in there, I came from another manufacturer and I worked for Netafim. I also worked for Jane Irrigation for 10 years doing just drip. So if you wonder where some of my passion came from, that's where some of it is. But yeah, all kinds of irrigation are great. This is a detail. I found a lot of details do not have enough information to build it. A lot of contractors have to build by the details and not so much by the plan. This has all the details. This is actually how to do sort of your standard drip system. These are called headers, and where the water comes in is called the supply header because it supplies the water. Where the water can be flush is an exhaust header because it can flush. And these are the rows of the drip line. Gives some example of staples. So we added 47 details. If you guys ever want those, we do have them online, but I also have flash drives I could give you. Just let me know. Maybe I could get a mass to Denny or something like that. I don't know. We'll figure something out. But I have some really good details. It's got catalog, everything else, just on a simple flash drive. And it also has some criteria about how far you can run the tube. Remember we talked about friction loss? Well, this makes it nice and easy. One, you could use a calculator, but this will say at 30 PSI how far you can run, like 289 feet with a 0.6. The other thing is the lower the flow rate, the farther you can run. The lower the flow rate, the less the entire system will cost. The only difference is you got to run the water longer. That's the main between the two. Now that last one was called an end feed because we fed, remember, from one end to the other. This is a center feed. So if you got to go some really long distances, this could actually feed here and go 500 feet this way and 500 feet that way. So some of the lengths you wouldn't normally do with, let's say, a spray system because you'd have to have a 2-inch, 3-inch pipe. With this, you're not. This is just 17 millimeter or half-inch drip line. It's small. You can bury it, put on surface. Lots of options. Tree rings. This comes up. There's a lot of ways to irrigate trees. I'm only showing a couple of them, but there's a lot more. This particular one is the same thing. The concept's the same. So if your valve's over here, come here, this is actually becomes your supply header. It's supplying water both ways. This is your flush. This allows, no matter what you're doing, to be able to flush if there's any debris that ever gets into the system. So that's a double ring. Get a bigger tree, maybe you do a triple ring. Somebody was talking about big projects. Well, the one at the Wen, we had a tree that was about 40 feet around. The actual root ball of the tree was 40 feet. And then we actually used a spiral design on that one. So everything would stay really moist while it sat before a crane craned it into the main pool area. And then what they would do is when they're ready, they would cut the system off at one point, then they crane the whole tree up, and then they drop it, and then they hook up the tubing again. Voila, it's already done. There's another type. This is for really low flow rates. You guys ever get into doing a lot of half-inch things, even if it's your own home? And one thing I should mention in the future, when you're at an office or whatever, and you want I call them lunch and builds or lunch and learns, or you want something done, we'll come out and do those for you. Be a much shorter format, but we can do, lunch for your whole office. It's a good thing for you that you bring us in. But the other thing that we can do too is if you need materials for your yard or parent's yard or whatever that is, we do that all the time. And the best way to do this stuff, the best way to learn it is to have it. I'm talking controllers, whatever. Got to be reasonable, but yeah, we do that all the time. So, or I'll get Fernando to do it if my budget's bad. So this is another way to do trees. If you don't want to have to, if you want to, you're going to flush here, but you can actually feed it all from one side. But if you have a square area where you're doing a metal grate that's
I
square,
personally lost your audio,
what's that?
but maybe I can't hear you anymore.
Oh, you can't hear me? Huh,
I wonder if the students can.
that's weird. Let's see what is going on. I can't hear you. I can hear you. I can hear you. Somebody can hear me.
Sorry, it's fine now. Sorry, it was.
Oh, it's all right. No. I'm just reading the messages. It's great having that, though. I mean, I've done that before. Going back and forth sometimes can be tricky. But here's a slope. This is a way, if you can picture this, this goes up. In this case, would be about 9 to 10 feet. So this is a 30-foot slope. This is a detail that shows you how to do it. So a lot of this stuff is done. We have them in PDF, DWG, JPEGs. They're all done. We already saw that. We don't need to see that again. This just shows all the variety of things that we carry and then how to specify, which is a nice thing to have, because when you want to do a plan, this is what you're going to throw in your legend. We also have those standard legends we can give you. So here's some different tools. These are pretty interesting. I told you how we make we make fittings fit the tool or tools fit the fittings. Rainbird is really big on not just producing the product, but producing something that's easy to install, because other things have been done the same way for, I mean, years and years. And now, if I can get these two on. I wonder if that would be that one. That should be this one. I'm
Yeah, I
gonna
think
try
so.
this.
My money would be on that one.
Your money's on that? All right, here we go. Let's go S&P. All right, here you guys can see this okay. We would have done this in person, but I'm gonna have to bring it to you like this. So, which is still good. These are two volunteers. And an office down in Dana Point in Southern California, and these two ladies for the very first time out of, I think there are 6 other guys there. They volunteered. And then, so what we're gonna have them do is, I call it the fitting challenge. And they'll try to first put on the competitor's fitting into the competitor's drip line, and then they're gonna try to put ours on. You'll see.
Go, Nicole! Go, Nicole! Go, Nicole! That's pretty good. Do it, Claire. Go, Claire. Go, Claire. Oh, he's rocking it. Got it, Claire. See you. No, you cannot do that. Too late. Team Claire. Team Claire. Did you get it? You got it. You got it? Face drill. Go. That's good. There you go. Good thinking. Remember. Now rock it. Look at that. Look at that. Uh-oh. Now you're good. That's good. Now you just got to take it out.
So it gives you an idea. It was their first go at it. I do those at every single appointment I go to. We've got a bunch of other reps doing the same thing. The reason is, again, you're not going to know until you do it. I find a lot of designers, you're sitting behind a computer 24/7, and a lot of the designers here, they don't even know what a valve looks like. You're already a step ahead of them. If you know what a valve looks like, and a spray head and a rotor and a bunch of other parts, and all the drip, most of them, they're on the computer. So you got a boss telling them, hey, I need this, and I need you to do a head layout, and just do it. And I bring in something, and they're like, oh, I didn't know what a control zone kit was, and now they know. So the more hands-on they can get, they understand it. It's like, okay, well, why would you specify Rainbird? Well, we're not going to specify Rainbird just because the drip line's better. Most people think drip line's all the same. They drip water, that's good, we're done. Most aren't thinking of 0.9 like one of your students was thinking of 0.9, which is great that they know that, but most don't. And so we have to have other things that differentiate, which is a systems approach. You see, everything that I like to do is a system. So you're showing that all those pieces go together. You're not leaving out any one thing, and you're make sure that you're always innovating. And we do so much new product development, we can't keep up with it. We have 4,000 SKUs, so it's a lot. I mean, it's a lot to remember. Anyway, but if I don't remember, I just ask Fernando. So here is the QF header. The headers I was talking about right here, see the PVC? That's typically how it's done. But if you get in curvy areas, you can't do that with PVC. There's no way. And you can see here how that works. And I'm not going to get into that. We did another one of those trials and compared a team doing PVC versus this. It's amazing. It's like, this is like, I don't know, probably 30 times faster, at least for them. This is a twist lock. It'd be better if you guys could actually handle this. I mean, you know, touch it, twist it, see how it goes on. These make it much easier to put the larger lines together. This might give you a nice idea. This is 14,000 square feet of subsurface drip under lawn. So this guy got...
Mark, we can't see your PowerPoint. We can only see the YouTube.
Oh,
stop share.
You have to share the different screen.
You're right. Well,
well, one of the students told me actually. I thought you were just.
There we go. There's us.
Yeah.
Okay, now let's try it. Now, I think they have a glitch because I do it like the same way every time. Anything? Is that any better?
We can see the PowerPoint now.
You can? Okay.
I think so.
What? Oh. How's that? Better?
Yes.
That one. Okay. So
if you can go back a couple of slides, then we can see what you were talking about.
All right.
Or
right here, right here would be better,
yeah.
Probably. Yeah. Did you see this one? Probably not. So this is just showing subsurface drip that's going to go under turf, and this was using that header, the plastic one, the QF header that bends. And there's about 14,000 square feet of this that were installed. This was originally done, I think, as a residence where there was a dad and his son. His son had never done this, and they actually did this fairly quickly. So it's a good example. Somebody I think has a question, either that or they didn't. Your students are right on top of it. That's great. Okay, so I should just like keep the video part on, be easier. This is a guy that's, I said there's different ways to install things, especially in existing turf. So I'm gonna see if we can get this back. Okay, can you see that? So, sort of interesting tool for smaller projects that don't want to remove their lawn. That's all you do. You just bend the tubing over, put a coupling and a screwdriver. This is what this guy did, pretty man-made, but what's nice is it will bury the tubing about 6 inches in depth, and it backfills over the tubing. So it's a
Wow, it's pretty cool.
Okay, now while we're on the video thing, I'm just gonna stay here. This is one I took at one of my former jobs, but I have mail. This is the one I mentioned in Edmonton. This shows how quickly a lot of people say, well, if there's too much drip line, it's going to take too long. So that's for a soccer field. So you can see there's 5 coils. They're 500-foot coils, and they can go in about 400 feet in 3 minutes, and bearing at 6 inches in depth and 18 inches apart. So it's good to know this because not everybody has this piece of equipment, but when you're doing larger jobs, this makes it cost effective, where if you were doing it with a regular trencher, not really. So
And you
Denny,
said,
go ahead.
you said that the 18 inches spacing is typical. So 6 inches deep is also typical. Is it, or does it change depending on the applications?
Yes, 6 inches in depth, 4 to 6 is typical for lawn.
Okay.
But as far as 18 inches, I'll just say 18 inches apart for drip line is for experienced users. Okay. Most in California do 12-inch because they're comfortable. It's not because the water won't spread that far. People forget that the technology came from Israel. In Israel, they watered all the crops. That's how they started doing drip line, because they couldn't be spraying and wasting all that water into the air. But anyway, it's all about soil type and having it move through the soil. So, but that's a very good question. And then anything else is, you could scratch it for regular shrubs, right, and put it under mulch, scratch the surface. So this was a video I made quite some time ago. It's been used quite a bit. Irrigation doesn't get watched that often. This one I have almost 19,000 hits because one, it doesn't have any words, and I think that's probably one of the good things about it. The other is it shows you from start to finish how to put in subsurface drip just yourself on a small area, not a big area. If you don't like the music, I can't do anything about it except you guys can turn it off. I like all kinds of music, so. But it doesn't work without the music. Watch fast. I mean, if you blink on this, I'm telling you, you'll miss it. There's a design. That's it. That's a great tool right there. There's the other tools. Rubber mallet, some stakes, piece of PVC pipe, not much, and a couple fittings. This is for a low flow system. Get an idea, that whole area is 1 gallon a minute. That's it, same as a spray head, 1 spray head. So this is a little technique, just backing up, using the spacer. So if you have a 12-inch space, this is 14, but if you had 12, you cut an 11.5-inch piece of PVC, and that'll get you right on. Some simple thing like this with the PVC will make the difference of doing a great job and a so-so job. You have to have the music too. I have been to a Pitbull concert, so don't judge me. Now, how do you do those tough areas? That's the key. Doesn't have to be exact. Remember, you're getting the whole thing wet. So you want to, I say test it before you bury it. Most don't. They just bury it. But I'm like, you know what? I want to get everything wet because I'm going to eventually put soil on this and sod. You can put your edging in before or after. It doesn't matter. With spray, you got to do your edging first. You should. This soil has actually a clay sand mix. It looks really light, but it's just off the truck. All you need is consistent soil. It could be clay, it could be sandy. Now this next shot, most wouldn't guess, that's a 14-hour time lapse. So to get it totally wet took 14 hours. Now we didn't need to use any PVC, so we decided to use it as a putter. But this guy couldn't putt, so we just let him go. I mean, fortunately I cut this off. Fortunately the song was long enough. We did this for like an hour. And it was 100, this is in Arizona, it's 105 degrees this day. So if you get the feel for it, you see the wind. So we re-rolled it thinking, oh, the ball maybe could go in now, get closer, same thing. I don't know if it was the golfer or the ball or the piece of PVC. I think it finally goes in. There we go.
Just
What?
to interrupt the fun with a boring question. So these kind of best practices you're showing, like the testing before burying, is that something that could go in a note in a construction document set?
Oh, in the notes?
Yeah.
Yeah, I think so.
I mean, the sort of, you know, prior to, you know, right after the installation, test before burying, you know, those kind of things.
Yeah.
Is it, okay.
Those are the things that it takes. Sandwich, Starbucks, and no muscle at all. It's a great deal.
Very nice.
So now that all looks good, but that's really not enough. It was only watered on the very first day overhead. Remember, 105 degrees. So this picture is taken 2 weeks later, all watering underground. 2 weeks.
Oh, wow.
People think you can't do it. You can do it. You just got to make sure it's moist first before you start. That's critical. If you don't moisten the soil that 14-hour time frame, remember, it's 14 hours, but you're only watering a gallon a minute. Not much water. Don't try this at home, but it is an ergonomic mower. That was the whole reason. There's a real mower we show later. That's 7 weeks, 5-inch root depth. Get an idea. This is actually TIF green, and I like to give credit to whoever helps with the video. It's super important to me is make sure that you always give the credit. And you want to make sure you talk about the soil sod mix, the sod roller, the TIF green, fertigation system I put in, which is the easy flow, potable water, the landscape architect, contractor, the maintenance guy, the video and photos directed by pretty much.
Who's the producer?
That was it. So anyway,
Fantastic.
that's all I could do. We're almost to the last one. So I wanted to show you that one especially because it did a lot of things for me too. It makes you realize if you're more systematic and you're trying to teach it. It's funny how that works. That's when I was actually at Netafim. That was 2008. So I still use that all the time. Not to just see myself. Most people don't think that's me in the video. They think I'm always talking like third person. Like,
Yeah.
But it's not so much that. It's the fact of just I got so frustrated, and I'm sure teachers got to have this. I had people at University of Arizona and some other schools that said, "Hey, can you come in here? I want you to do a talk on this, on how do you do turf." I'm like, well, hey, I'm not in Arizona, but I'll send you a link. I sent him a link and he would use it in class. Took him, 10 minutes and, worked. So this one, the company I worked at before, a couple companies ago, they actually went to the owner of NetFM, the president for the United States, and said, we want to do the same video. Because they wouldn't do it. They didn't want to do social media. They want to do it. They were old school and all that stuff. I'm like, whatever, I'll use it. And then they come in. They said, we're going to charge NetFM $18,000, and we're going to hire a director, and we're going to hire an actress, and we're going to do about the same thing. And he can write it. He can whatever. And actually, it was good. I just don't think it was as good because it wasn't as fun. Once you start doing too much of the professional, I'll show you a professional video that I helped with this one, which I think this is getting more interest as the spaces get tighter and tighter. We get, with trees, get tricky to water. So I showed you the tree rings, a lot like the tree rings. Others, like on the tight spaces, they like to use our watering system, which is the RWS. And this is a good video. I actually had them working some of the design into this, which they had never done. And I'm like, who does most of the specification of these? Who does the biggest part of the sales is specs. Over 70% of this is specified, which is huge, compared to other products. So this is a video that just gives a nice overview. It's a little bit, whatever, manufacturing, but
it easily connects to irrigation lateral lines or can be installed in drip zones. Specifying the RWS on irrigation plans is quick and easy. First, place the RWS units and connect them to your irrigation system. Next, assign a detail in the Irrigation Manager. Irrigation contractors can reference the details and see exactly how the RWS should be installed. The RWS is available in 3 sizes: 36 inches for large to medium-sized trees, 18 inches for small trees and large shrubs, and 10 inches for smaller shrubs and trees. For existing trees, position units evenly spaced half the distance between the tree trunk and the edge of the tree canopy. For large to medium-sized trees, use 3 or more RWS units. For small trees and large shrubs, use 2 RWS-M units. And for smaller shrubs and trees, use 2 RWS-S units. For large to medium-sized trees, equally space the RWS units around the root ball, with no more than 30 inches between them. For smaller trees and shrubs, place the RWS units on opposite sides of the plant material. If shrubs or trees are spaced less than 12 inches apart, use 1 RWS-S between each plant. For sloped landscapes, install the RWS uphill from the plant material, and be sure to specify RWS units with check valves. For existing trees or shrubs, use a 1- or 2-man auger to drill holes where the units are needed, and make sure the holes are slightly larger and deeper than the RWS unit. Integrated polyethylene swing assembly and spiral barb fittings connect to PVC and PE pipes. For extremely hard or clay soils, consider adding 3/4 inch pea gravel beneath the unit to help with water distribution. An optional cloth sandsock prevents soil from penetrating the unit during the backfill process, and over time, especially with sandy soil. You can also fill the RWS canister with pea gravel to provide firmness against root compression. Be sure to install the RWS level to finish grade for a clean appearance. The 1400 series bubblers on the RWS are pressure compensating full circle bubblers with flow ranges from 0.25 to 1 gallon per minute. For sandy soil, consider using higher output bubblers. And for hard clay soil, use cycle and soak programming along with lower output bubblers. Be sure to check out the video on converting the RWS for surface irrigation, or visit our website for more information.
That was that.
Good.
The end. What you're not supposed to say at the end of a.
So it's the end of your presentation?
Yes, that was the end of the presentation. Well, unless it could be more, it just depends on what you want.
Fantastic. Thank you so much. I mean, maybe there's questions from the students, or can give them a few minutes. They can type, or you can also show yourself or talk.
Show yourself.
I know.
That was extremely
I see.
informative. Oh,
I see Lou. To everyone, you probably see it then. Thank you for presentation. It was really helpful seeing the layout of spray. And so.
Yeah, and it
Here we go.
says, how do you determine the actual irrigation rate based on plants' water use? For example, for plants with low water needs, how many gallons of water do they need every day? And how do you decide on irrigation schedule and frequency?
That's probably another class. That's another class. No, I'm sure you've heard of that Model Water Efficient Mwello. On there, we do have a calculator that we've been working on, because there's different things you have to consider. It depends, one, on the region you're in. So there's a sheet that has all the different evapotranspiration for all the different regions, and then all the different low, medium, and high water plants. So you can do those calculations and the scheduling. So it's not really, unfortunately, it's not really super simple. Even the legislation or the cities, Southern California being more MWD, and Northern California, there's a lot of different agencies that make it a little bit more complicated. It's tough to go to one place. And a lot of times they don't do like automatic spreadsheets, so you've got to like just sort of almost figure them out by hand. But if you want one, send me an email and I can send you one that's an example. It's not finished, but I haven't had anybody say they don't like it, and it would help with what you're asking.
I have a question about, because some of the students are working with rain gardens, these kind of areas that eventually will hold some water. And I assume, and I've seen the plants, they're planting them with sort of low water, with plants that actually like water. So this may be a stupid question, but would you apply irrigation to those areas also for the times where water doesn't, for summers, for instance, if it's.
Are you talking about bioswales or detention basins?
We're talking about essentially just rain gardens, areas where water will collect at some point and sort of allowed to sort of percolate into the ground. But of course, my thought is, what if it doesn't rain for months? The plant material is going to need some kind of water. And so have you seen, how would you approach it?
Well, the biggest thing would be to put it in a separate zone. Not everybody's probably going to think of that, but most of the irrigation designers would do that. They would put it in a zone by itself, for one thing. It depends too on the grade. If the grade's under 10 feet or something like that, you could do the drip 18 inches even farther apart, especially if the plants already like the water. And you could even do possibly moisture sensing might be a good application for that. Mm-hmm. Or if it's more commercial, you could do what we have some do is they'll actually do a temporary system. They'll put the drip in and run some unions or something on one end, and then they'll pull it back, and they'll only use it as needed, or they'll just use it to get the plants established.
Mm. Yeah. Good. Yeah, that was my only question.
That's a good question. Instructors always have difficult questions.
Okay. Questions from the audience?
Questions for the audience?
For the audience.
Yes.
I think we...
It looks like they, I mean, it was very, very thorough, I have to say. I really appreciate the care that you put into it, the amount of information you provided, but also how you were able to, you modeled it, you know, you even did a little role playing. So it's really, it was fantastic. Actually, it was very, very good. So I don't know if the students have any more questions. I have to log off at 3:30, but I wanted to first, so they can continue, they can ask you questions. And I have Mark's email, of course. We have him nearby, so we can always bug him maybe
Yeah.
if you have any additional questions.
Same here too, guys. If you guys ever need, I'll ask Mark to share my information as well. I always have to contribute back to my alma mater. Anyways, I forgot to mention that. So.
Oh, okay, great. Oh, fantastic. Thank you also. It's been, the two of you are working very well together. So I just wanted to thank you, Mark, for all of this. And I think Audrey also is thanking you for allowing, you know, for making this presentation happen. Appreciate the time you put in and the energy, and we learn a lot, I think. So
Great.
I have to log off. Thank you so much.
Great. Thank you.
Yeah.
Have a great rest of the day and great Thanksgiving.
We'll be in touch. Happy Thanksgiving to you.
Thanks, Danny.
Thank
Okay,
you.
bye.